Hi class, today's lesson is lesson 3-2. It's on estimating decimals. Purpose for today is to estimate decimal sums, differences, products, and quotients. Essentially what we're doing is we're using estimation with all operations involving decimals. First vocabulary term is the term clustering. Clustering. Clustering is when you're rounding numbers to the same value. Let's talk a little bit about this. There's a difference between rounding, which you know how to do since, boy, second and third grade, versus clustering. If we were rounding these numbers to the nearest 10, 47 would go to 50. 44 is closer to 40 than 50, and 51 would round down to 50. That's what would happen if we rounded. Now if we cluster, however, we take a look at the numbers in general and we can see that they cluster around 47, clusters around 50, 44 clusters around 50, and 51 clusters around 50. So they're all around the number 50. So there's a difference between rounding and clustering. Next, we have some front-end estimation. Now this is part of looking at of estimating range, but let's look at this specifically. What's the front-end estimation part? Well, this is only using the whole number part of a decimal. So as we look at 42 and 251 thousandths with 134 and 65 hundredths, what we essentially do is we essentially take the decimals out of it, and for front-end estimation we use the 42, or we use the 134 in this case. Now in terms of range and estimating a range, we're going to do some of this front-end estimation, and then we're going to do something also with the decimal portion as well. Stay tuned. Here we have example 1. This is a look at clustering. Billy wants to cycle, play hockey, and water ski. If Billy weighs 90 pounds and spends 45 minutes doing each activity, about how many calories will he burn in all? This table, although it doesn't say it, is a table that is designed specifically for somebody that is 90 pounds. So let's take a look at what Billy wants to do. He wants to cycle, he wants to play hockey, and he wants to water ski. So how much will he burn in all? Again, here it says about, which allows us to estimate about how many calories will he burn in all. Well, there's the data. So what we're going to do is we're going to go ahead and take a look at these the amount of calories burned in each activity and add them up. Of course, we're not going to add them up. We're going to estimate their addition. So in clustering, what we would notice is that each of these numbers is around what number? Well, they're all around 200. So we're going to make this 200. We're going to make 210 and 6/10 200. And then we're going to make 194 and 4/10 200. Now, this is really rough. It's not really rounding, but it's a very rough rounding, which is called clustering. So 200, 200, 200, he's going to burn about 600 calories doing all these activities. Example 2. Example 2 is what we're used to. It's about rounding. Rounding decimals to estimate sums and differences. Estimate by rounding to the indicated place value. Here we have a problem, an addition problem, that they want us to round to the nearest ones place. Well, in order to do that, we're looking at this, of course, and we're judging it based upon what we see in the next place value, which is the tenths. So 3 9200ths rounds to 4, plus 6 and 4800ths rounds down to 6. 4 and 6 is 10. Over here, same sort of thing. Only this time we're rounding to the nearest hundredths. So when we round to the nearest hundredths, we're looking at this and this. So instead of 8 and 6,355 10,000ths, we're going to write it as 8 and 5. Looking at this 5, we round up so that 6,400 subtract 5 and, looking at that now, we round up again, 400ths. So 8 6,400 subtract 5 and 400ths gives us 3 and 60/100ths. Or another way we can say that is 3 and 6/10ths. That's rounding. Now let's look at compatible numbers. We've learned this before as well. Compatible numbers is looking for, in this case, we're estimating each product and quotient. We're looking for easy numbers to work with. Here we have 26 and 76/100ths times 2 and 93/100ths. When we're estimating, I'm looking for an easy way to do this. Now 26 is pretty close to 25. That's an easy number to deal with. Yeah, it's not rounding up or rounding down, but it's a compatible number, especially when I pair that with multiplying by 3, because I can easily do this in my head. 25 times 3, 75. Compatible numbers. Same thing over here. What can I do to make these numbers easier to divide? Well, as I look at this, 42 and 64/100ths, it's close to, well, it's close to 45. This is pretty close to 15, and I know 15 goes into 45 very easily. 45 divided by 15 is simply 3. So there are my two estimations using compatible numbers. Final example is front-end estimation. In this case, we're going to use front-end estimation and a little more. It says estimate a range for the sum. So I'm looking at the sum of 9 and 99/100ths plus 22 and 89/100ths plus 8 and 3/10ths. Now line them up here, and what we essentially do is we ignore the decimals for the front-end estimation portion. When we ignore the decimals, we have 9 and 22 and 8. So the front-end estimation part of this is, well, what's 9 plus 22? That is 31, plus 8 is 39. So our answer is going to be at least 39. Now what we do is we take these decimals that we've discarded and we round those essentially to the nearest. Are they closer to 5/10ths or are they closer to 1? In this case, 99/100ths is close to 1, 89/100ths is close to 1, 30/100ths is close to 5/10ths. So what do we have in the end? Well, let me put the point zeros here, because remember the zeros don't matter when you add it to the end of a decimal. And we have 2 1/2, or 2 5/10ths. What does this tell us? Well, this tells us that for our range, our estimated range of this sum is somewhere between 39, which we know is on the short end of the range. It's between 39 and 39 plus 2 5/10ths. We're looking for the upper end of the range. It's 5/10ths down here. 9 plus 2 is 11. We have 41 5/10ths. So in other words, what this is saying is our actual answer is somewhere between 39 and 41 5/10ths by using front-end estimation and then taking those discarded decimals and rounding them to either 5/10ths or 1. Finally, to complete the problem. For number 1, you're going to tell what number the following decimals cluster around: 34 and 5/10, 36 and 7/800, and 35 and 234 thousandths. And then number 2, it says determine whether a front-end estimation without adjustment is always an overestimation or an underestimation. If I glance back at this, this is front-end estimation with adjustments, because we adjusted right down here. So the question here, and there's the adjustment, the word adjustment. The question here is whether the front-end estimation without adjustment is always an overestimation or an underestimation. And be prepared to explain why in class. All right, we will see you in class then.